And I'm live. That is cool. Today is 15th of November 2025, Saturday. And with that, let's just begin. Screen is visible and everything is cool. And yes, we will need some structure, learning Go. So we will be using Boot.Dev for Go. And yeah, Boot.Dev is like pretty cool. And there is this course which we will be going through and Boot.Dev. That is pretty nice. But there is by Mr. Lane Wagner. He is Lane Wagner, whatever. He is the creator of Boot.Dev and he has a 9 hour, 30 minutes video on in which he is going through the whole course. So that is pretty cool. That is pretty cool. Go full course. Yeah, go. And with that, let's just go. We understand the basic stuff about Go and maybe some theoretical stuff also. And yeah, let's just go. Variables, these are chapter lists, and the first chapter is just variables. So we start the course. And yes, the first few first three chapters are free, and I guess from the fourth one, yes, on the fourth one we will go into the guest mode and we won't be able to submit our solutions from fourth chapter on. But before that, in the first three chapter, we can submit our solutions. So that is pretty neat, I would say. And that is cool. Go. That is criminal profiling or Go. This course assumes you are familiar with programming fundamentals in at least one other programming. Yes, we fill that criteria, I suppose. I will move quickly through the basic. For example, I will explain how functions in Go work, but I will assume you already know what a function is. Yes, if you are brand new to programming, I recommend starting with Python for beginner course. What to expect for most of this course, you will be writing code in your browser, okay, but we will occasionally drop down to your own local machine and use your own CLI tool written in Go, of course. Yeah, we will create our own CLI tool in another course in the same website. We will be building parts of a make-believe software project. Textio, okay, software as a service, SaaS application for sending text messages to customers. Okay, assignment: print starting Textio server to the console instead of hello there. Shit, that is the assignment. Okay, starting Textio server. That was the whole assignment. And yes, package main import format the main function and submit, and that is ah shit, that Go is supposed to be fast at compilation. Confettis, and we go. Yo, I am already level 33. Look at that. That is too much XP. That is just too much XP. Basic variables. Boolean. Okay, we have Boolean. String is also a basic variable in Go. I guess this is string at the stack and not the other kind of string, right? Yeah, not at heap. A boolean, true or false, string, integer, float, and byte. Declaring a variable the sad way. Okay, there is the sad way. Declaring where name type and then equals this number. The first line where this defaults this variable to its defaults MySQL issues variable to its zero value. On the next line, 42 overwrites the zero value. And why 42? Because 42 is the answer of the whole universe. That is what shit. I don't know who said that, but yes. Mm, yes, someone said that. Isaac Asimov or some science fiction writer. Douglas Huxley. or I'm messing things up. We will talk about a better way to declare variables in the next session. Okay, what is the assignment? Initialize the variables from the print statement to int, float, 64. This is with their zero values respectively. With their values respectively. Okay, so here we have variable SMS sending limit. So that is V. What is a V type? Has we integer? So 0. We'll have to say explicitly that this is an integer. And then was per SMS, that is float. So F64, F, F64 or 32, 64, yes. Float, not just F. Float 64 equals 0.0, and then where has permission, and that is a string. Nope, that is again V. V is for Boolean. Okay, so bool equals false, and then where what sh- sh- what would be the default value of a string? What would be the default value of a string? There's zero values. I guess just an empty string would be good enough. Let's see if this actually like runs. Hello, damn, let's go. And why not Rust or Zig since you are from C++? I'm also learning Rust, like Rust offline, off stream, because yes, Rust is more difficult than this. Yep. And Go here on stream. I need Go for assignment that I have to do. So yeah, why not on stream? Seems cool. And yes, we did that lesson. Let's go. Goated variable declaration. Okay, this is the basic lame variable declaration, and this is the goated one. Here we use this thing called the shit. It literally is called the walrus operator. Okay, the walrus operator declares a new variable and assigns a value to it in one line. And also, my bad, I should give a link in the description or at least in the chat for the course. Learn Go here. Here you go. Error. Try again. Well, you can see it on the stream, so yeah, go there and you can do stuff. Can I not send any message? I can send hi. That is cool. Now, yes, there is this other declaration which is walrus operator, and this is the goated variable declaration method. Declares a new variable and assigns a value to it in one line. Go can infer that my skill issues is an int because of 42. Yay. Type inference. Type inference. When the compiler deduces what the type of a variable is and assigns that type to the variable. That is cool. This walrus operator should be used instead of var style declaration basically anywhere possible. The limitation is that this cannot be used outside of a function in the global package, which we will talk about later. Okay. Type inference is based on the value being assigned. An integer, float, string, bool. Assignment. A common use case of Textio is to send birthday messages. So, okay, shit. Let's give this message start as well, hello there. You are now, and then age equals, let's say, 42, and message end would be equals to years old. So happy Birthday. That seems like someone would want to hear that. Shit. Age, undefined age. E makes sense. Walrus operator. Sure, I should increase the font. My bad. I should increase the font. Yes, that looks much better. Cool. Next, should we? Wait, what? Huh? This was still wrong somehow. Submit and try again. Okay, what is the error? Shit. Okay, assignment is complete main function. It should print happy birthday. You are 21 years old. Shit. Okay, okay. We cannot just say whatever you want. Okay. Happy birthday. You are now. Yeah, we were off by like twice the age. This years old. Exclamation mark. Create a string variable this, age to this. Right. Provide the fmt println statement with printing assignment will print full message on a single line separated by spaces. Okay, now we should be good. Happy birthday, you are now this many years old, and submit. And cool, we got some XP. That is cool. Daily streak increased by 1 day. That's also cool. And why Go? Go is my favorite programming language by a good margin. Why? Fast and lightweight, easy, concurrent, easily concurrent. Like it takes advantage of the fact that a CPU itself, a single processor, can have multiple threads and there can be multiple cores inside a processor. And I misspoke. Instead of processors, I should say a single core can have multiple cores. A single core can have multiple threads, and a processor can have multiple cores. So that is cool. And yeah, generally a core has two threads. Easy and simple, compiled, statically typed, garbage collected. I don't know how compiled and garbage collected go together with each other. We'll talk more about the benefits of Go later, but for now, let's whet your appetite with some more code. Okay. Assignment. Critical bug. The text users reported that we are billing them for wildly inaccurate amounts. They are supposed to be billed $0.02 for each text message sent without changing any of the other lines. Fix the math bug on line 8. Cost per message plus number of message from Doris or whatever. Okay, we have to multiply this thing, right? Cost per message into the number of messages. That is nice. And yeah, that should work. 1.44. And if we submit, yeah, that is cool. That is cool. Comments. Go has two style of comments, slash slash, same as C and C++. The new intern on the team screwed up their documentation. Comment fix the issue. Shit, they actually did screw up. That is cool. Yeah. Okay, so this one is a forward slash. This one is a back. No, they are both forward slash. Submit code and cool. Gained. Points gained. Let's move forward. That is cool. The compilation process. Computers need machine code. They don't understand English or even Go. We need to convert our high-level Go code into machine code, which is really just a set of instructions at some specific set of instructions that some specific hardware can understand. In your case, your CPU, which is ARM64 assembly, or not even the assembly, the binary representation of that assembly. The Go compiler's job is to take Go code and produce machine code, an exe file on Windows or an standard executable on Mac/Linux. That is Excalibur. They are using Excalibur for all of this stuff. Code, Go code goes to compiler, which is Go build. It makes an executable. Go program is structure. We will go over this all later in more detail, but to state your curious to sate your curiosity, package main lets the Go compiler know that we want this code to compile and run as a stand-alone program as opposed to being a library that is imported by other programs. Makes sense. Import format. Imports a formatting package from the standard library. It allows us to use fmt.print line. Function main defines the main function, the entry point for a Go program. Okay, that is cool. I've seen this also in Rust. They make a pretty distinctive distinction between a package, between an executable package and a library. So yeah, that is one thing in these newer languages, in Rust and in Go. That is cool. Two kinds of errors. Generally speaking, there are two kinds of errors in programming. Compilation error occurs while code is being compiled. It is generally better to have compilation errors because they will never accidentally make it into production. You cannot ship a program with a compilation error because the resulting executable won't even be created. Makes sense. Runtime errors occur when a program is running. These are generally worse because they can cause your program to crash or behave unexpectedly at the user side. While we are in the browser, it can be a bit hard to tell the difference because we run and compile the code in the same step because this is interpretation. Run the code, notice the compilation error, it is due to invalid syntax. Yes, because we do not have a ending thing here. Fix the compilation error in the code. Now we are good. Submit and confettis and yo XP increased. Fast and compiled. Generally speaking, languages that compile directly to machine code produce programs that are faster than interpreted languages because for interpreted languages there is our interpreter, the whole program which is running, and that itself, the language is running on top of the interpreter. So generally they are slower than compiled languages. Go is one of the fastest programming languages, beating JavaScript, Python, and Ruby handily in most benchmarks because they are all interpreted and Go is compiled. Just that bare fact is cool. However, Go programs don't run quite as fast as its compiled Rust, Zig, and C counterparts. That said, it compiles much faster than they do, which makes the developer experience super productive. Unfortunately, there are no sword fights on Go teams. Okay, shit. So that makes sense. That makes sense. The number of program I execute for legitimacy is lacking off. My code is compiling. Yo, yeah, that makes sense. Go code generally runs dash dash then runs faster than interpreted languages and compiles faster than other compiled languages. Faster. Yo. Next, type sizes. So we saw that there are integers, float 64, string, boolean. Shit, we don't have characters in Go. We do have byte, which is like character, 8-bit data. Yeah, we do have bytes. Integers, unsigned floats, okay, type sizes. Complex numbers are natively inbuilt, which is like messed up. Signed integers, okay, for different sizes. Signed integers, no decimal, without decimal, okay. Integer 8-bit, integer 16-bit, 32-bit, or 64-bit. Or unsigned integer in the same category, or unsigned pointer is also something. Then float 32 or 64, and complex number 64-bit or 128-bit. What is the deal with sizes? The size, this, etc. represent how many bits in memory will be used to store the variable. The default int and uint is 32 or 64. Type depending on the environment of the user, the standard sizes that should be used unless you have a specific performance need. Example, using less memory are the standard sizes that should be used unless you have a specific performance need. Example, using less memory are int which is 32-bit, int is 32-bit, or an uint is also 32-bit, and this is like stand written that this is 64 bits, and complex number is 128 bits because it has, that is quite a big thing. 128 bits, that would be like if we treat, yeah, this is 128 bits because you need space to store every possible configuration of the of a 64-bit, yes, of a 64-bit normal integer, and it's a 64-bit real integer or float or whatever, and then it's 64-bit complex counterpart. So yeah, 128 bits, 64 into 64 bits, we can just add them. Yeah, 128. Some types can easily be converted like this. We have a float, we can convert that into an integer, causing a float to an integer. This way truncates and we lose precision, we lose the 0.26 part. Assignment, our TO customers want to know how long they have had accounts with us. Okay, on line 7, create an account age integer variable and assign it the value of account age float, truncate to an integer. On the 7th line we have to do this. Okay, account age int equals int and account age float. Let's see, and we submit and we'll see how this goes. Yeah, confetti, and we got experience. This is gamified version of programming, so that is cool. Okay, and what should I use? So with so many types for what is essentially just a number, and the only factor which is changing, not only factor, there are different types of numbers. A normal integer, then numbers with decimal, which are floating numbers, and then there is complex numbers. So yeah, those are the three representations, and they each come with their own sizes. So yeah, those are the only two variables which are changing, factors which are changing. Developers coming from languages that only have one kind of number, like JavaScript, shit, may find the choosing daunting. Prefer default types. Okay, they are preferred default types. A problem arises when we have a unsigned 16-bit integer and the function we are trying to pass it into takes an integer. So that is a problem because there is no um, implicit conversion of things in Go, I suppose. We are forced to write code riddled with type conversions like this. Yeah, so that is not very good. This style of code can be slow and annoying to read when Go developers stay from default stray from default types for any given type family. The code can get messy quickly. Unless you have a good performance related reason, you will typically just want to use the default type. So yes, they are just telling us that we should use default types because we do not want type conversions everywhere in our code. That is not very good. My age normal with a unsigned 16-bit integer, and then my age in integer format. We do not want this. That is very bad. And we have bool, string, int, unint, byte, rune, rune is some type. Everyone type in Go. Let's see. Yo, hello, how is everything going? And let's go. You see the pun in there? And yes, long time no see. Rune in a Go is a built-in type that represents a Unicode point. It is an alias for a okay. So underneath the hood, it is just an integer which takes 32 bits, and we are using the rune little word when we want to use that 32-bit integer as a Unicode character. So that is cool. Just like in C++, we have it's char. Yes. Underneath the hood, it is using the same facilities. If we would, yeah, it is similar to the way that we have size type in C++. That is cool. When you are super concerned about performance and memory usage, then you are, I guess, a pro programmer already and you don't mind this. That is about it. The only reason to deviate from the defaults is to squeeze out every last bit of performance when you are waiting on an application that is resource constrained, or in the special case of Uint64, you need an absurd range of unsigned integers. You can read more. Nope. When should you elect not to use default type? When performance and memory are the primary concern. When my system has lots of extra hardware I want to utilize. No. When either a default or a specific size will work. No. Okay, if that is wrong, yeah, would have been funny. But yes, we are getting a lot of experience. That's good. What should I use? That is the same thing here. What does the size of a type indicate? Kilobytes, nibbles, bits. 64 bits, 32 bits. And yes, nibble is 4 bits. That is something. Go is statically typed. That is the type. I mean, what char is in C, same. It is in rune, more or less. Yes. Shit, you also know Go. That is quite a lot of things. 1 billion row challenges in Go, I guess. Go enforces static typing, meaning variable types are known before the code runs. Before the code runs means when it is being compiled. Yeah, so compiler knows the types. That means your editor and the compiler can display errors before the code is ever run, making development easier and faster, unlike JavaScript. Constraint this with most dynamically typed languages like JavaScript, contrast, not constraint, contrast with like JavaScript and Python. Dynamic typing often leads to subtle bugs that are hard to detect. The code must be run to catch syntax and type errors. Sometimes in production, if you are unlucky, we run shit, yes, to catch syntax. I guess the LSP can catch the syntax errors, but not the type errors. Shit, type because syntax also changes with types. So yes, LSP won't even be able to tell us. In JavaScript we can even do if we have a number equals 1 and then do number dot 5, that would work in JavaScript. This would not give us error in JavaScript. So yes, syntax also we have to check by running the code. That is crazy. Languages also have strong or weak typing, meaning stricter or weaker type checking rules, whatever. Yeah. Two strings can be concatenated with the plus operator, but the compiler will not allow you to concatenate a string variable with an integer or this. Yeah, makes sense. And then TextView uses basic authentication to log in users. The code on the right has a type error. Yes, we are adding a string with the integer. Change the type of the password to string. Don't tell the answer, but use the same numeric value, so that can be concatenated with the same username variable. Can we do this? Let's see if this runs. Hello. Go is pretty sexy language, okay, except for its quirkiness, like using cases, lower and uppercase. Yes, yesterday I was writing something and we have to write give the name of a function in uppercase if you want to export it, and that is kind of cool. Global scope of variables or making it necessary to write braces on the same line. Okay, I haven't experienced all the subtleties and quirkiness. I will have to, but yes, the uppercase and lowercase one I did experience a little bit, and that was cool actually. Okay, shit, this is wrong. Go feels like writing Python in C. Writing Python in C. We do not have, yes, the fact that we do not have any mm, brackets at the end is crazy. Any semicolons at the end, that is like tripping me. Okay, that should run. And is is it over for me or should I start learning Go as well? Shit, shit. I guess you can learn Go. It depends. You are also learning DSA at the same time. You are getting into competitive programming. I mean, you can decide. You can, if you can at the same time, that is fine. But also, like, do not do too much. Yeah, cool, cool. Compiled versus interpreted. You can run a compiled program without the original source code. Yes, makes sense. You don't need the compiler anymore after its job is done. That is how most video games are distributed. Players don't need to install the correct version of Go to run a PC game. They just download the executable game and run it. Makes sense. And yes, they are also using Xciltra, which is pretty cool. Production environment, example, a server. On the server, we have executable. Only the compiled executable runs in the production. No compiler required. Code, compiler, executable. Code, source code copied to production. Code, code and interpreter required in production. Okay, that is and here we have interpreted languages and here we have compiled languages. With interpreted languages like Python and Ruby, the code is interpreted at runtime by a separate program known as the interpreter. That is why they are slower. The language is running on top of another program, so yes, slower. Distributing code for users to run can be a pain because they need to have an interpreter installed and they need access to the source code. I mean, source code, shipping the source code is not very difficult, but shit, I guess the size of the source code is greater than the size of the binary after compilation. That would, yeah, that should be true. You can type semicolon and then Go compiler won't mind. Yes, yes, we can type it, but there is also the fact that you don't have to. So that is cool. This is like Lua. You don't have to, but you can if you want to. Then the best part of Go is it is compiled. It's compilation time. It compiles so fast. Sometimes I wonder if I did some mistake in the code or missed the write sometimes. So totally opposite of Rust. Shit. Because Rust is, yes, Rust is bad. Rust is bad. Rust is bad. Shit. Because I think in Rust we also have to compile the libraries which we are using every time that we are compiling the whole thing. So, and yes, borrow checker checks everything. So the three basic rules of Rust and the mutable and immutable references also. I was thinking to add Go learning on weekends would look good in my profile. Just a thought. I'll follow your learning curve. Shit. Okay, you already are working in a company and Go is not very complex. Shit, we have a video. We will watch the video. Yeah, so this would be pretty cool for you. This course would be pretty cool. Boot.Dev. Blindly installing precompiled binaries is also not a good idea. Precomp. Yes. I mean, yes, the other option is you can build from source, which is, yeah, which feels cool. You can say I built it from source. That is like I use ours, by the way. But I'll have to put on the headphones. My bad. Yes. And shit, shit, shit. Yep, camera is still working. That is pretty cool. Ah, yeah.
Compiled languages are faster than interpreted languages. Interpreted languages have better developer experience than compiled languages. This is some of the stuff that I'm hearing online. Let's actually break it down and talk about the difference between a compiled language and an interpreted language. When we write code, we write it in a human readable format. Right?
Shit. Uh, while watching this video, my camera must be over his face, which is not very good. Let me put away my camera on the other side. Yeah, cool.
Right? Typically in a file, in the case of
And
Go, a
shit, is this audible? Yes, this
.go
is.
file, right? Maybe main.go.
Yeah.
And this file is going to contain human readable text, right? Go code that we as developers work on. The thing is, your computer's hardware doesn't know what any of that human readable text means. Your computer's CPU only understands binary, right? Which is ones and zeros, right? Which at the end of the day is just numbers, right? But it's just numbers and simple operations, things like add and subtract. So we need some process that we can use to convert human readable code to machine code that can be executed by the computer's hardware. And that's all that compilation is. Compilation is just the process of taking some human readable code, right? Go code in our instance, and converting it to binary or machine code that our computer can actually understand. So, what does this process actually look like? Well, normally you'd start by writing your Go program. So, say main.go. And you'd run it through the Go compiler. On your command line, you'd type go build. And that would produce a new file, which is the executable program. Let's say we were doing a hello world program. It might be hello world.exe, right? An executable program on your computer. And then you could run that executable directly on your operating system without ever having to use the Go toolchain again. So the great thing is you can take this hello world.exe program and give it to someone else, and they can run it on their computer without ever having to install the Go toolchain or even know that you used Go to build the program in the first place. This is different than languages like Python, where if you want to run someone's Python code, you have to use the Python interpreter every single time, and you run the source code directly on your machine. It's also worth pointing out that part of the reason that compiling is so much faster at runtime is that we do all of this compiling work up front. So when we go to run the executable, we don't have to do any conversions from human readable text to binary machine code. That's different than how interpreted languages work. With an interpreted language, as we run the program, the interpreter is reading the human code and kind of at runtime converting it to machine code that the CPU can operate on. Not to beat a dead horse, but I want to talk a little bit more about execution speed. So we talked about how Go is generally faster than the interpreted languages, right? Python, JavaScript, Ruby, PHP, and so on. It gets a little interesting when we compare Go to kind of the natively compiled languages or the languages that compile directly to kind of machine code that runs on your CPU versus the compiled languages that run on top of a virtual machine. Right, so the two big ones that run on a virtual machine are Java and C#, while some of the compiled or natively compiled languages that you'll be familiar with might be Rust, C, C++. Even though Go is a natively compiled language, a language that compiles directly to machine code like Rust, C, and C++, its execution speed is actually more similar to Java and C# when it comes to its runtime speed, how many computations it can do kind of per second. And we'll talk more about this later, but the primary reason for that is the Go runtime. There's basically a chunk of code that's included in every Go program that manages memory, and that tends to slow down the execution speed a little bit. That said, it is worth pointing out that a Go program tends to use much less memory than Java and C# because there isn't a need for an entire virtual machine.
That does make sense. And I was wondering why, like, how is Go compiled, and also Go has a garbage collector. So that is kind of crazy. Go, yes, Go does include garbage collector, and the Go's garbage collector is shipped with the binary itself. That is kind of crazy. And run nm command on it. Okay. FYI, there is a machine code interpreter that the OS provides, also machine code interpreter. So that is like emulation for some other operating system or our own. And wait, nope, not Rust, but Go. Hello, Go build hello.go. What do we even have in hello.go? We have some stuff. Okay, and yes, nm. Okay, shit. This is the address of things. So that is got a lot of stuff. Nm nm.exe. Okay, all of this. What is this? What is nm? Nm make what? Shit. Nm LLVM nm display name less save symbol tables so that is like in every executable there is a part of it which has symbols, and this is symbol table. Hello, good afternoon. And it is slightly different than code interpreter. It takes care of dynamic linking and other stuff. Okay, machine code interpreter like with Java. Gotta go now. Okay, cool, bye. I have someone walrus to catch up on CP. Shit, bye. And pipe it to word count L line and see how many lines that is. Yesterday contest went bad. Shit, I didn't stalk you for yesterday's contest. My bad. Word count, line count the number of lines, that is 2209 Okay, so let's write main.rs and and yeah, let's shit use. I forgot. What do we write here? What do we write here? Use std shit println is always there without doing anything else. Yeah, println is there. So yeah, that is cool. We don't have to do this. Print ln this, and of course hello world. Rest c main.rf main or whatever, and nm on this main wc word count length 1184. And for equivalent Go program, if we just print stuff on the screen, uh, print ln on this, print ln hello dot world Google hello and hello word count 2528, which is like one less than 29. And yeah, the difference is half. And if we write in main.cpp, this feels home. Okay, let's use std cout hello world, end line. Yes, C++ main dot cpp out nm. So that took quite a bit of time. nm Let's see. Shit, that is messed up. That is quite messed up. That's messed up. Look at this. That is just 12 symbols. That is just shit. Shit. That is just glue. Shit. That is just 12 symbols. That is crazy. That is like actually crazy. Implemented a compiler? Nope, I have not implemented a compiler. Shit, it was 11 and now 11. Write a simple C and yes, that is just 11 symbols. CPP standard lib would be massive. It is fine. Standard. Okay, we are not importing the whole library. I guess we didn't do in Rust. We are not even importing anything. But there is the preamble which gets attached at the top of each Rust code. So there is also that. And in Rust, if we don't do this and we do this, C++ source files are not allowed. We're not using shit. Okay. Print ln. We didn't have to use the \n, but anyways, go build hello dot go and nm hello word count 1007. Okay, that is much better. If we are not including a library, so that is cool. This is really cool. Just 12 symbols. Main.cpp s yes output main.s. I guess that should work. Okay, shit. That is obsolete and it is a Tame Impala reference. G++, not carriage operator. Main.cpp, capital S, main.s, and main.s. These are the symbols. They seem to be the symbols. Yeah, those are the only symbols being used. This is one, yeah, just 12 symbols. So that is like pretty cool. That is pretty cool. Compile C or CPP code with static flag. Okay. No, it is dynamically linked. Dynamically linked. Uh, Shit, it is dynamically linked. Hmm. I okay, I don't actually know how to link things dynamically because how would you link things dynamically? What is dynamically linked? Rest is static linked. Yes, because of the preamble, and it will be bigger, but the overall standard library size is way smaller in Rust. Dynamically linked. So, but main.s here for dynamic linking, where are we calling the thing? Because when we are running the file, what is there is not a path here, or if I were to write this thing by my own, why does this say arch for architecture? Makes sense. LC0 link cache 0 stack pointer get stuff. Let's use a normal thing and n main.cpp, and yes, we are getting off topic. But this is fine. Uh, printf hello world and g++ main.cpp capital S out main.s. Now, where is the printf call? Puts. We are repeatedly calling puts, but we are not specifying where puts is. Okay, I'll have to see how dynamic linking is done because we are not linking anything while we are calling the function. Yeah, we are not linking anything while we are calling the function. So, and I don't know if there is a part of this main.s code. Why is this an executable? Yeah, I don't know if there is a part of this main.s code which is calling the linked library and then main.s word count line 3. That is even more messed up. That is crazy. Hello. Bro, can you tell the difference between lead code and CP and which is value for time? Uh, okay, value for time question we will see, but lead code and CP. In lead code you get pure, I would say, pure mathematical questions like you have a stack and array and stuff like that, and you have to do this or that. Pure algorithmic and data structure related questions, and in CP there is time constraint and there are contests and you have to be quick on your feet in CP. Lucid or liquid intelligence is something that you require in CP, and there are contests which you have to give, and you have a rating in CP, and there are also contests in lead code if you want to give them. Yeah, there are also contests in lead code. So yeah, I would say if you want to get better at DSA, then go with CP instead of doing just pure lead code. Yeah, doing CP is much better than doing just a lead code. And I'm making a small Python project today. A small game load. Yo, let's go. Let's go. That is pretty cool. Run LLD and provide the binary LLD linker. Okay, shit. LLD. What is LLD? Shit. LDD. My bad. I guess this is not here for Mac. LDD command not found. This might be Linux specific and there must be a equivalent linker. Shit, yes. Linked like dot LLD. That is a Windows thing, right? Dot LLD. And in this we have dot A files which are dynamically linked. And yes, getting back to the see go back to go. To run a compiled program, users need blue here is very compelling, but the compiled executable is the correct one. Why I will text you in a compiled language. One of the most convenient things about using a compiled language like Go for text you is that when we deploy our server, we don't need to include any runtime language dependencies like Node or a Python interpreter. We just add the pre-compiled binary to the server and start it up. That is nice. And the same thing here. And his name is Boots, I guess. Which language is interpreted? Python. Yo. Same line declarations. Okay, on the same line we can declare multiple things. That is pretty cool. You can declare multiple variables on the same line. The above is the same. Yes. Assignment. At the top of the main function, declare a float, average, open, read, and a string called display message on the same line, and give them these values. Okay. Average, open, rate, and display message will be equal to 0.23 comma is the average open rate of your messages. Is the spelling correct? Is the average open rate of your messages? We can optionally include a semicolon and submit. And LLD linked libraries, dynamically linked libraries. 120 XP, that is a lot of XP. And small memory footprint. Go programs are Go programs are fairly lightweight. Each program includes a small amount of extra code that is included in the executable binary called Go runtime. Okay, one of the purposes of the Go runtime is to clean up used memory at runtime, the garbage collector. It includes a garbage collector JC that automatically frees up memory that is no longer in use. That is cool. And shit, you are right. You are right. I think we don't have to provide specifically and say that when you are running this executable, link these given files, because I think that is handled at the compiler level. Because even at the assembly level, we can just say, no, shit. The linker does it. Shit. Yes, you are like absolutely correct. The linker does the thing, but the symbols that we saw using the nm function, they were given to us, they were read to us from, okay, so yes, because of the data that we got out of the nm function, we know that there are not a lot of extra things in this uh, compiled binary. So this things must be dynamically linked. That is true. Things must be dynamically linked. Yes, things must be dynamically linked. Here we don't have a lot of symbols. Okay, that is cool. That is cool. We can think about it later. Yes, now this. Generally speaking, which language uses most memory? Shit. Generally speaking, ah, Java would. Oh, that is correct. RL memory usage. Shit. That is messed up. That is kind of messed up. In the chart above, Dexter Switch compares the memory usage of three very simple programs written in Java, Go, and Rust. As you can see, Go and Rust are very little memory, use very little memory when compared to Java. Java is massive. 162 MBs is actually messed up to Java. And let's watch the video. Yep.
Go, Java, and Rust all have very different approaches to how they manage memory, which can have a huge impact on program performance. And there are two things that we mostly care about here. One is speed, how fast your program can do computations, which is roughly measured in the number of CPU cycles required to get the job done. The other is memory usage, that is, how much memory, usually RAM, the program needs to store its data, or your program's variables, while it does those computations. In languages like C, Rust, or Zig, memory management is effectively manual. You as the developer explicitly allocate memory by writing code that says, hey, this chunk of memory will store this data. And later, your code signals that it's done using that memory so that it can be freed up and used by other programs. In Java, things are different. Java's garbage collected, which means that memory management is automated. In Java, it's handled by the Java Virtual Machine, or JVM. When you run a Java program, you're actually starting up a virtual machine that executes your Java program's compiled bytecode. The JVM is responsible for allocating and freeing memory on the fly as it's needed. But this automation does introduce some overhead, and Java programs often use more memory than equivalent programs or similar programs written in languages like C. Now, Go falls into an interesting middle ground. Like Java, Go's garbage collected, so memory management is automated. But unlike Java, Go does not use a virtual machine. When you compile Go code, you get a single natively compiled binary just like you would with Rust or C. The difference is that this Go binary includes a runtime. It has an extra bundle of code that is compiled into every single Go executable. This runtime is what handles the garbage collection, other features like Go routine scheduling. One important aspect of Go's memory management is that it's often able to allocate more data on the stack than a language like Java does. And stack allocations, when possible, are more performant than heap allocations. So as a very generic rule of thumb, Go programs tend to use less memory than Java or C# programs, but because Go is still garbage collected, it does tend to use more memory than programs written in C or Rust.
That is nice. That is the brilliance of Ken Thompson, I would say. Okay, and I can move back my face to that side of the screen. Yep, cool. That is the brilliance of someone like Ken Thompson. We get the benefits of garbage collector without slowing down the language. So that is pretty cool. That is pretty cool. Best of both worlds, speed and garbage collection. What is one of the purposes of Go runtime? Garbage collection, to compile code, to clean up unused memory, to scrape off JavaScript developers. Yes, that is the correct answer. To style Go code and make it easier to read. Nope, to clean up unused memory and code. Constants are declared with const. Okay, and shit, okay, we use var, and here we are using constant, but we are not using the auto walrus operator here, because since this is a constant, this must be initialized right now. And since a constant is initialized at the time of its declaration, then I guess we don't need a walrus operator because it will be auto deduced from the right side. They cannot use the walrus operator. Short declaration syntax. Constants can be primitive type like string, integer, and string is just an array of characters. Booleans and floats, they cannot be more complex. Types like slices, shit, Rust also has slices, maps, and structs, which are types we will explain later, okay, in due time. As the name implies, the value of a constant cannot be changed after it has been declared. Use two separate constants. Something weird is happening in this code. Premium plan, constant, edit, don't edit code below this. Okay, and what should be happening is that we create two separate constants, premium plan name and basic plan name. Right now it looks like we are trying to overwrite one of them. Okay, complete as basic plan. Is that it? Basic plan, and create the constant basic plan. Ah, shit. Ah, yes. Ah, basic plan name, basic plan name. B is not very capital. And submit we do. Shit, B is not capital because of how Go handles upper caps lock, uppercase and lowercase, case sensitiveness. Computed const Consonants. Okay, we can compute consonants like constant expression in C++. Constants must be known at compile time. They are usually declared with a static value like this. However, constants can be computed as long as the computation can happen at compile time. That is called compile time macro. That said, you cannot declare a constant that can only be computed at runtime like you can in JavaScript. This breaks. You that said, you cannot declare a constant that can only be computed at compile time, at runtime. Makes sense? Makes sense. So we can initialize a constant, but only with the value if the values which we are using to initialize the constant depend on constant values or values which can be calculated at compile time. That is cool. Don't edit code below this. So seconds in minutes, 60 seconds in 1 minute makes sense. And then seconds in seconds in hour into minutes in hour. And yes, that is it. Complete the code using a computed constant to print the number. Yes, submit. Let's go. And yes, confetti, that is cool. Gained experience. Comparing Go's speed. Go is generally faster and more lightweight than interpreted or VM powered languages like Python interpreted, JavaScript interpreted, PHP interpreted, Ruby interpreted. Java is VM. Wait, Ruby might actually be VM based, I don't know. However, in terms of execution speed, Go does lag behind some other compiled languages like all of these like OG languages. Not Rust. Rust is not OG. Rust is a new gangster. Go is a bit slower, mostly due to its automated memory management, also known as the Go runtime, is slightly slower. Speed is the price you pay for memory safety and simple syntax. That is like really cool. I want to be able to write more complex programs in Rust in Go because we don't have to care about memory. That is pretty cool. That is very convenient. Textio is an amazing candidate for Go project. We will be able to quickly process large amounts of text all while using a language that is safe and simple to write. Does Go generally execute faster than Rust? Nope. Formatting is strings in Go. Shit. Okay. Go follows the printf tradition from C language. In my opinion, okay, of course it copies stuff from the C language because this is made by Ken Thompson. IMO string formatting interpolation in Go is less elegant than Python's F strings, unfortunately. Okay, FMT printf prints a formatted string to standard output, and sprintf returns the formatted string. Okay, that is nice. That is nice. Prints a formatted string and this. Okay, these following formatting verbs work with the formatting functions above. This one, v variant prints the Go syntax representation of a value. It is a nice default. Okay, we can use this for anything, I guess. That is cool. I am way too many years old. Okay, if you want to point in a more specific way, you can use the following formatting keywords. For a string, we use %s. For integer, %d. And for float, %f with precision also if you want to. If you are interested in all the formatting things in the FMT package, we can go to the docs, but we won't. Assignment: create a new variable called MSG, Messenger of God, MSG, on line 9 and use the appropriate formatting function to return a string that contains following. Hi, name your rate is operate percent new line. Okay. Saul Goodman. Shit. Saul Goodman. That is nice. Replace name with the variable name in the message thing. Okay. Const, we have to make a const new variable or constant, does not matter. MSG equals, yes, fnt dot s printf, right? Yes, s printf, and here we'll say hi string comma, say your open rate is operate v percent new line. The new line we will add new line, and uh, round it to the nearest 10 tens place. Example, this should be rounded to down to nearest place. So percent 0.1 f, only one digit after the decimal, makes sense. This much percent and new line. That is nice. And here name comma open rate, and this should work. Hopefully it does not work, even though these two things are constants. It's all good, man. And 30.5, that is nice. We then put Jimmy McGill, and 2.5, the expected output would be this. My name is Jim McGill. And new line. Shit. Close, your output is a few characters. Oh. Huh. Hi, Saul Goodman. You're not you. Your open rate. There is a space between open rate is this thing, percent new line, PERCENT. PERCENT, that is nice. And yo, which website is this? This is Boot.Dev. Okay, gained experience, 360 experiences, quite a bit. And I have seen many shitty LC profiles getting selected in Fang. Shit. This is this website. Nope, I haven't purchased the premium. I can only submit, or anyone can, if they don't have the premium, they can only submit for the first 3 chapters till functions, and after that, we are in guest mode. Yeah, we just have to assume that hopefully we did the right thing. Learn Go, nope. Good. Runes, yes, that is correct. In many programming languages, co- see, a character is a single byte. Yes. Using ASCII encoding, the standard for C programming language, we can represent 128 characters with 7 bits. Why do they use 7 bits? 7 is like, yes, okay. This is enough for the English alphabet, number, and some special characters. In Go, strings are just sequences of bytes. They can hold arbitrary data. However, Go also has a special type, rune, which is an alias for int34, int32. This means that rune is a 32-bit integer which is large enough to hold any Unicode point. Yes. When you are working with strings, you need to be aware of the encoding. What does the byte represents? Yeah. Goes to UTF-8 encoding, which is a variable length encoding. That is, some characters just use 1 byte, some characters use 2 bytes, some characters use 3 bytes, and some use 4 bytes. Emojis use more than 1 byte. I guess at least 2 bytes. And what does it mean? There are 2 main takeaways. When you need to work with individual characters in a string, you should use the rune type. Makes sense. It breaks strings up into their individual characters, which can be more than 1 byte long. Yes, we can include a wide variety of Unicode characters in our strings, such as emojis, Chinese characters, and Go will handle them just fine, or Japanese or Hindi characters, anything. Boots is a bear. He is Boots. This guy. He's called Boots. Boots is a bear, not a dog. Haters. He's, who would call him a dog? He is a bear. Haters. Run the code as is. Notice that the simple string boots have 5 bytes and 5 runes, characters. Boots. Okay, constant name. Byte length is this length of this. Okay. uh, okay, and then UTF-8 rune count in string. That is nice. So run this. And second, update the name variable to beer emoji. Shit, okay, this vim is kind of strange in here. Shit. Uh, shit. I cannot paste this thing because this Vim which is running here, it is not linked with my clipboard. Shit. Okay. Okay. Control V does work. That is nice. Okay. Control V does work. That is nice. Run and beer. Yeah. Rune length is 1, but this takes 4 bytes. Yeah, that is quite a bit of difference. 80 XP, that is nice. And move on to the next lesson. Fix small bugs. The code that prints server logs won't even compile. What is the problem in here? Well, first of all, this, and then don't touch anything below this. And why is this a integer? This is a string, and now it should work. Don't touch code below this line. Confirmation message and startup. That should be correct. Yes, that is correct. Submit and confetti is cool. Fix bugs. Someone doesn't know about walruses. Pitiful. Caledon. Shit. The words Caledon. You have to speak the words. The words. Okay. And is there any other error? Sender name, recipient, recipient, and message. Message is also fine. So that is cool. And this should compile. Cool. Sly. Caledon. Right. And then run type interface. Type inference 2. This is an integer. Pennies per text. 2 pennies per text. And what is T? Our current price to send a text message is 2 cents. However, it is likely that in the future the price will be a fraction of penny. So we will need to use float 64 to store it. Edit the this declaration pennies per text declaration so that its interface by the compiler as a inferred by the compiler like a 64-bit float. There we go. Okay, %t is for type. That makes sense. Here %t is for type. Float 64. And format practice. You have been asked to improve the logs to include information about individual users and their recent messages. Okay, assignment, create a user log variable on the line 15. It should contain this thing. Okay, on line 15, they specifically tell us where. Okay, and user log. Okay, name. Shit, this will be given to fmt dot s printf function, right? And let's have stuff here. Percent s, a string, and then another string, and age should be an integer. It is an integer, which is like d, and then message rate is a float, so percent f or 01f. That is nice. And subscribe, is subscribed is a boolean, which is is subscribed is a boolean. We'll use v. And message is a string, does make sense. And then we'll give everything in name, l name, and then page message rate, and is subscribed, and then message. Okay, shit. FMT is print. What is the error? Message rate is not used. Undefined message rate. Okay. Message rate and submit confetti. Yo, let's go. That was it for the first lesson. That is cool. Why don't you develop a game using Raylib? There will be probably some Raylib bindings for Go. We can do that. We can do that, but not right now. Right now, I want to get into this. And yeah, Raylib is pretty cool. We just did Game of Life in Raylib. That is cool. I will do some Go. And yeah, of course, we'll do some other things in Raylib, but not right now. Yeah. If statements in Go do not use parentheses around the condition. Okay. Oh shit. Okay. If is not part of this whole statement. If is different. Yeah. Else if and else are supported as you might expect, but they have to be on the same line that the ending bracket ends at. Fix the bug on line 12. What is the bug on line 12? Message len greater than message len. Don't touch code above this line. Okay. On line 12th, there is an error println. This one. There is an error on this line somehow. Fix the bug on if message len is less than or equal to greater message, the program should print message sent. Okay. That is a like abstract bug. Else it should print message not sent. Cool. Wait, this is conditionals. Okay. And if the initial statement of an if block, an if statement can have an initial statement, the variables created in the initial statement are only defined within the scope of the if body. That is nice. So they are defined, but can they also have been assigned? Yes, they can also be assigned. So that is cool. Why would I use this? It has two valuable purposes. It is a bit shorter. It limits the scope of the initialized variable to the if block. For example, instead of getting a length variable here and then doing this there, we can do this on the same line. That is pretty cool. In this example, length isn't available in the parent scope, which is nice because we don't need it there. We won't accidentally use it elsewhere in the function. Why would you use the initial section of an if statement to speed up my code, to keep the code concise and compile, to confuse, to speed up my code, to keep the code concise and scope limited? Cool, and which is valid Go syntax. This thing. We don't use parentheses here. That is nice. And the switch statement. Yes, variable, create the variable, switch on OS. OS is the input, and if Linux, then Linus Torvalds, Windows Bill Gates, Mac Steve, and then otherwise default is creator unknown. If there are any other operating systems. Switch statements are a way to compare a value against multiple operations. They are similar to if-else statements, but are more concise and readable when the number of operations is more than 2. Notice that in Go, the break statement is not required at the end of the case. That is, yes, noticeable to stop it from falling through the case, through the next case. The break statement is implicit in Go. Okay, it is like it handles the break by itself. If you do want a case to fall through to the next case, you can use the fall through. All three of these cases will set creator to Steve. Case macro is fall through. Steve, that is nice. New goal challenge, fix event bug variable scopes. Shit. What's that? Challenge, except shit, this is the challenge. Okay. Your ticket pricing program prints the wrong number because some variables are shadowed or reassigned incorrectly. Short variable declaration. This creates a new variable and can shadow an existing one. Use this to assign to an existing value when you intend to update it. Learn more here. Okay, fix the program so it uses the provided constants and variables to calculate and print the correct values. Calculate and print the correct values. Print exactly these 3 lines in the order. Base price 50, VIP price per person 75, and total revenue is 165. What do you have here? We are creating a scope and here mistakenly shadowing free service with. This makes VIP price wrong. Service fee 0. VIP per VIP person is service fee plus everything else. So we can just remove this. Service fee is already defined there. So that is nice. And this, that is nice. Then mistakenly shadows attendees and changing it to lead to wrong total. Why would this happen? Attendees equals attendees plus 1. Attendees is 3, so it would become equal to 3. Okay, that should be nice. Detail base price is a constant value 50, 75, 165 is the thing that is required, but we are getting 220 because base ticket price. No, there's some mistake with this. FMT, this is red somehow. 165 now. It is nice. Base ticket price is constant with value 50. Service fee is a constant with value 5. Update attendees is 3 calculates. Yeah, okay. So we just had to remove those two lines, and that was the whole assignment. That is cool. Confettis. Done. Okay, and back into my old ways. Right here we have switch statements. That is nice. We don't need a break inside the switch. And if we want to fall through, we can use the fall through word. That is nice. The default case does whatever you expect. You didn't expect. It is the case that runs if none of the other cases match assignment. I know we haven't covered function syntax in depth, yes, but bear with me. Fix the bug in billing cost function. The basic plan is set correctly, but we need matches for the pro and enterprise plans too. If the plan is pro, the constant should be 20, and enterprise, the cost should be 50. Basic, then the cost should wait for basic. The cost is fine, but we have to change cost for the other ones. Case pro, in case of pro, return 20.0, and then case for enterprise is return 30.0. Cool. Enterprise, and here we say pro, and this should compile. Yes, very fast compile time. I'll go. Configures. Cool. In calculate balance, we need to calculate the total cost for a batch of messages and update the user's balance if they have enough money. For a batch of messages and update the user's balance if they have enough money. So reduce. Using the given variables, write conditional statements to calculate and update the variables. Okay, this is all we have. Insufficient fund message purchase success. Message account balance, bulk message cost is premium user, discount rate, final cost. Don't edit above this and inside this. Don't edit below this. We have to edit inside this. Set final cost to bulk message cost. Okay, bulk message cost, and then if the user is a premium user, apply the discount rate to the final cost. So if is premium user, if premium user, then apply rate discount rate, that would be final cost equals 1 minus discount rate multiplied by final cost. That is nice. Do not edit below this line. Origin price. Okay, if the user has enough money in their account balance, then reduce the final cost from account balance. Print the purchase message. If not, just print insufficient fund message. So if after getting the final cost, if account balance is greater than or equal to final cost, then we do have something, and we'll say account balance minus from this final cost. Yeah, that is cool. And also fmt dot println a string with a new line at the end, and that is purchase message successful. Else, if that is not the case, then account balance would just stay whatever it is, and print ln%s new line, and here we have, here we'll be printing insufficient message, yes, and print run. Okay, why do we see literally a print s there? Percent s. Makes sense. We are not using printf, so yeah, makes sense. But she is successful. Cool. And submit. Let's see how this goes. And you gain 282 experience. That is cool. And now the third chapter for this 1 hour and 35 minutes. That is cool. Okay, functions. Functions in Go. Okay, what have we done till now? We have seen conditions, if conditions, switch statements, but we have not seen while loops. We have not seen loops. Loops will come way later. That is okay. Loops will come after structures and interfaces. That is a long time. That is a really long time, but okay, that is fine. And we saw variables. What did we saw in variables? On Go, basic y Go comments, types, different types of variables in Go, formatting practices in Go. That is fine. And now functions. And yeah, there are 21 things in the functions chapter. Functions in Go can take 0 or more arguments. But the amazing thing about these functions in Go is that they can return 0 or more arguments, like any number of arguments, return values. So that is cool. To make easier, to make code easier to read, the variable type comes after the variable name. Yes. Xint, yes, variable type comes after the variable name, which is kind of wacky. For example, the following function, this, yes, accepts two integers and returns an integer. This is called a function signature. The name, input types, and the output type. Assignment. We often need to manipulate strings in our messaging app. For example, adding some personalization by using a customer's name within a template. The concat function should take two strings and smash them together like this and fix the function signature. Concat. Okay. Yes, there is an error. We don't know the types of S1 and S2. They are both string, so that is one thing. And also, instead of this, let's see first if this runs, which it does. And instead of this, we can omit this string here and see that both of these are strings. Then submit. Cool. Now multiple parameters. Yes, they can take multiple parameters of any type. Here, both of these are integers. Both of these are integers. This is a string. Both of these are integers. This a string and then another integer. When multiple arguments are of the same type and are next to each other in the function definition and each other in the function signature, the type only needs to be declared after the last argument. Here are some examples. What of the following is the shortest and cleanest way to write a valid function signature? Valid. This is cool. First name, age. So that is wrong. This is wrong. This is not very cool. This doesn't even make sense. This one is the best. using test lessons. Okay, up until now, all the coding lessons in this course have been testing your code based on your code's console output, what is printed. For example, a lesson might expect your code in conjunction with the code we provide to print something like this. If your code prints the exact output, you pass. If it doesn't, you fail. Right. A new type of lesson. Going forward, you will be encountering a new type of lesson, unit tests. If you take a course with us, if you have taken a course with us before, you will know what we are referring to. But in case you haven't, a unit test is just an automated program that tests a small unit of code, usually just a function or two. The editor will have tabs, the main.go, shit, and test.go, main.go file containing your code, and the main test.go file containing the result tests. There's new unit test style lessons will test your code's functionality rather than its output. Functionality rather than its output. Our tests will call functions in your code with different arguments and expect specific return values. If your code returns the correct value, you pass. If it doesn't, you fail. Okay, there are two reasons for this change. It is more realistic. The real world, you will be writing tests, unit tests, and running them against your code to make sure it works and as expected. You can run and debug your code with FMT format, print line statement, and leave those print statements in where you submit. Unlike the output-based lessons, you won't have to remove your FMT print line statement to pass, because this does not depend on the output. This only checks the return value of a function. Get monthly price takes in a string and returns an integer. Assignment: complete the get monthly price function. It accepts a tier string as input and returns the monthly price for that tier in pennies. We can use a switch statement here. Switch on tier, that is case basic. What we have to do is return 0, 100, and then case premium, return 150, and case enterprise, return 500. That is very nice. Convert the prices from dollar to pennies. If nothing matches, then yeah, default return 0. Cool. And fail. Enterprise expecting this much in pennies, so we have to multiply everything by 100. Makes sense. And pass, everything pass, submit, and see how that goes. Cool. Gained 160 experience points. Declaration syntax. Wait, didn't we use? Shit. That is messed up. What is this? That is a nightmare. That is C style syntaxing. Shit, that is crazy. Developers often wonder why the declaration syntax in Go is so different from the traditional established established in C family of languages. C style syntax. The C language describes types with an expression including the name to be declared and states what type that expression will be. The name and the type makes sense like this int y. The code above declares y as an integer. In general, the type goes on the left and the expression on the right. Yes, and the expression on the right. Interestingly, the creators of Go language which is Ken Thompson, Rob Pike, and one more guy, agreed that the C style of declaration types in signature gets confusing really fast. Take a look at this night. Yes, Go style syntax, Go's declaration are as clear, you can just read them left to right, just like you would in English. X is an integer, P is a integer pointer, and A is an array having 3 integers. It is nice for more complex signatures. It makes them easier to read. Okay, so we have a function which takes in a function which takes in 2 integers and returns an integer. And also this takes in an integer. And then the whole main function returns an integer. And that is cool. That's cool. That is like actually readable. What are we talking about when we discuss declaration syntax? When we discuss declaration syntax while we are declaring either a variable or a function or something. The value of language used to create new variables, types, and functions, etc. The ever important question of tabs versus spaces, nope. The decision about whether to use camel case or nope. The argument over guard clauses and versus if-else statements, nope. The style of language used to create new variables, types, create new variables, not give them value, but create. Declaration syntax, the same thing here. Which languages declaration syntax reads like English from left to right? Go. And yup. Next, same thing here. And given the following, this f is a variable of type this. And what is this type? This type is a function. F is a function that returns an integer but takes in a function and an integer, and the internal function that f takes in as a parameter, that function takes in 2 integers and returns an integer. What is a function named f that takes in an int as an argument and returns an int? Nope. A function named f that takes in a function as its argument and returns an int. A function named f that takes in a function and an integer as argument and returns an integer. Yes. Cool. A function named f that takes a function and an integer as arguments and returns a function. Nope. That one is the one. Passing variables y value. Yes. That is something we would like to know. This is copy. Variables in Go are passed by value except for a few data types we haven't covered yet. Are passed by value. Okay. Pass by value means that when a variable is passed into a function, that function receives a copy of the variable. The function is unable to mutate the caller's original data. I guess C++ reference syntax is pretty cool in this stuff. We can just pass in references to stuff. So that is pretty cool. Fix the bugs and monthly bill assignment here. Yes. When we pass x to the increment function, nothing happens. Fix the bug in the monthly bill increase and get bill for month functions. Monthly bill increase. This one. This one returns the increase in the bill from the previous to current month. If the bill decreases, it should return a negative number. Get bill for month. Okay, and get bill for month returns the bill for the given month. It looks like, okay, this takes in a bill, cost per send, and messages sent. Okay, but we shit, return an integer, and last one will equal to this one will equals to this, and this should run. Shit, or it would not run because these values are not actually initialized. The habit. Yes. We don't even know how to pass these. Wait, we might have to pass. Yes, we don't have to pass these. That is nice. The function signature for get bill for month runs. Yeah, cool. Submit. And we do see the confetti, so that is pretty satisfying and cool. Let's move forward. Ignoring return values. A function can return a value that the caller doesn't care about. We can explicitly ignore values using underscore. Yes, blank identifier by using an underscore, or more precisely the blank identifier. This function returns 3 comma 4. Get point. Get to the point. Okay. We do not want second value, we just want that first value. We will take 3 and we will not take 4. Even though get point returns two values, we can capture the first one and ignore the second. In Go, the blank identifier isn't just a convention, it is a real language feature that completely discards the value. Why might you ignore a return value? Maybe a function called get circle returns the center point and the radius, but you only need the radius for your calculation. In that case, you can ignore the center point variable. The Go compiler will throw an error if you have any unused variable declarations in your code. So you need to ignore anything you don't intend to use. That makes sense. Run code as it is. You should get a compiler error. Fix the get product message to ignore the unused return value. Product message. Return three things here, three things here, and get product message. We don't use the description. Yeah. Yup. Submit, and that does run with confetti. We gained XP. Shit, we are almost 35 level. Named return values is also something which is like actually crazy. Return values may be given names, and if they are, then they are treated as the same as they were new variables defined at the top of the function, which is just crazy. Okay, shit, that is like actually crazy. Years until drinking. Okay, named return values are here. There's also package main, import this, and testing, test all of this. Okay. Named return values are best thought of as a way to document the purpose of the return values. Makes sense. And then a return value without arguments returns the named return values. A return statement without arguments returns the named return value. This is known as naked return. Okay, a return statement without arguments returns the named return values. That makes sense. That does make sense. Naked return statements should be used only in short functions. They can harm readability in longer functions. Use naked returns if it is obvious what the purpose of the return value is. Otherwise, use named returns for clarity. X and Y are initialized with zero values, automatically return X and Y. Okay. That is very nice. and this is the same as this. Okay, shit, these are initialized right here. That makes sense. That is like actually cool. And then assignment. One of our clients likes to send text messages reminding users of live events coming up. Okay, fix the bug by using return values in the function signature. By using return values in the function signature and order them as they appear in the code. Do not alter the body of the code function. Okay. All of these are integers, so we can just do this and we can say years until adult and years until drinking, years until car rental, and that is how things are passed in. One was skipped. Let's see. And cool, confettis. That is actually pretty cool. And yeah, let's do a few more lessons because this feels a bit dense. Even though this all of this is simple stuff, this just feels a bit dense because the brain needs time to adjust to new information. The benefits of named returns. Good for documentation, understanding named return parameters are great for documenting a function. We know what the function is returning directly from its signature. No need for a comment. Makes sense because the name describes what the value describes. Named return parameters are particularly important in longer functions with many return values. Makes sense. Error type. Return 00 error new cannot divide by 0 makes sense. Which is easier to understand than this. Yeah. Mul div and error. Okay, we know the meaning of each return value because it is literally written here. Makes sense. Less code sometimes. Nil is the return value of an error. Some more on this later. Okay, more on this later. If there are multiple return statements in a function, you don't need to write all the return values each time, though you probably should. Okay. Uh, if there are multiple, you probably should. When you choose to omit return values, it is called a naked return. Naked returns should only be used in short and simple functions. Naked return. That is something. When might you use naked returns in for small functions, for small functions, not for complex or large functions? That just does not make a lot of sense. And next, the benefits of return values, we just saw them. And when should named returns should be used? When there are many values being returned, that is a valid argument. When there are a few parameters being returned, no. When there are many values being returned, then is it good? When function is simple, return naked shit. Okay, that was wrong. When the function is simple, that is not the thing. Okay, when should named returns be used? When there are many values being returned. The first try was better. Explicit returns like return this, return implicit returns x and y because they are defined here. Even though a function has named return values, we can explicitly return values if we want to, like this, or we don't. Fix the bug in the code. Let's see what the bug is. We are supposed to be returning 3 things, and we are always returning them to be equal to 0. And fix the bug so that it returns the name valued explicitly. Yes, until adult. drinking, and car rental, and those are the only things. Submit or run. I don't know the shortcut for submit. That is run. That is cool. Confettis. And early returns. Go supports the ability to return early from a function. This is a powerful feature that can be cleaned up, and we can also here listen to this lesson if you want to. Guard clauses leverage the ability to return early from a function or continue through a loop to make nested conditionals one-dimensional. That is something. Go supports the ability to return early from a function. This is a powerful feature that can clean up code, especially when used as guard clauses. Guard clauses leverages the ability to return early from a function, or what is guard clauses? Guard clauses is this thing, I guess. Guard clauses leverage the ability to return early from a function or continue through a loop. Or continue through a loop or return early makes sense to make nested conditions one-dimensional instead of using if else. That makes sense. That makes sense. Instead of this, we can just use if return, if return, if return. Yeah, makes sense. The example above is much easier to read and understand when writing code. It is important to try to reduce the cognitive load on the reader by reducing the number of entities they need to think about at a given time. Right. Because when we are at this if statement, we know we didn't pass any of the others, because if we did, we would have returned. In the first example, the developer is trying to figure out 270 is returned. They need to think about each branch in the logic tree and try to remember which cases matter and which cases don't. With the one-dimensional structure offered by guard clauses, it is okay. This is called guard clause, not cause. Guard clause, which is cool. Okay, it is as simple as stepping through each case in order. Yes, makes sense. Stepping through each case in order makes perfect sense, and which is true. Guard clauses provide a linear approach to logic trees. Yes, that is one. Yes, yes, yes. Oh, guard clauses are unreadable. No, they are readable. Guard clauses are generally worse than nested. No, first one is true. Early returns. Yes. What is a guard clause? A guard clause is the ability to linearly reduce a logic tree to linear individual if clauses. An early return from a function when a given condition is met. Yes. Yes. Okay. And functions as values. We can first class functions. Yes, first class functions are functions which can be used as values, like in Lua. Yes, in Lua also we can pass in functions as values to other functions, or take functions as values returned by other functions. So like lambda functions in C++. Go supports first class and higher order functions, which are just fancy ways of saying functions as values. First class. And functions are just another type, like integer, string, boolean, and etc. Let's assume we have two simple functions like this, add and multiply. Then we can create a new aggregate function that accepts a function as its fourth argument. ABC, all of them are integers, and then an arithmetic function. Should that is just crazy. This calls and arithmetic A and B. First result and second result is arithmetic, first result and C, and then return second result. Okay, it calls the given arithmetic function, which could be add or multiply, or any other function that accepts two integers and returns an integer and applies it to three inputs instead of two. It can be used like this: aggregate these three values, add them, they become 9. 4 plus 2 plus 3 is 9, and then multiply these, 12, 24. Yes, assignment: complete the reformat function. It takes a message string and a formatter function as input. Return formatter, which takes in the message, and that should work. Fail. Shit. Hello there, add period, expecting text you. Text TIO and a space and then plus. Let's see if this runs. This should, does not run. Add period. There we have to call this 3 times, it seems. Add a prefix, return, apply the function formatted 3 times to the message. Okay, 3 times. Formatter. That is cool. Let's see, submit the code and cool. There we go. And I guess that would be the end of today's stream. Because I kind of feel overwhelmed. I need to take a break and go take a walk. We have gone through 3 chapters. Chapter number 1, even though these are basic, but it's still, yeah, this is taking some memory load, and yeah, that would be the end of today's stream. Yep, that would be the end of today's stream. We did some basic stuff in Go in Boot.Dev. That is cool. Yeah, that would be it for today, and thank you for being here. Bye.